Hey Dave, did you get a chance to take attendance last time?
Yes, we only had one student who wasn't able to attend the class, and he actually sent a note explaining that he had a conflict, uh,
Oh,
but that he
okay.
was
So must have been
rearranging.
Wei then.
Yes, I believe so.
Oh, okay, cool, good. You plan to take attendance? How do you plan to do it
Yes.
today or
Yeah, I was
from
going
now
to do
on?
it. What I'm going to try and do it is in the background and then verify it just before we go to break.
Okay.
Uh, that
So
way,
it,
that way we could just, uh, if I find the student's name, they'll get credit for being here. If they filled out their name correctly in the participants list.
okay. So you don't need to do it at the beginning of the class.
Yeah, I was going to do my best to minimize the interruption of class with it. We'll just do it just before going to break to make sure that everybody has gotten credit.
Okay. We'll start at classes 9:05 to see if there are more people coming. Thanks, Dave.
I just realized that I had my camera covered. Sorry about that.
We can see you.
Hey, everybody.
Took some allergy medicine last night, so I'm not quite out of it yet.
Oh, and Van, one of the things to always make sure that I've done is as we start the class, let's make sure that I have uh, designated you as a co-host in case something happens to my connection
Mm-hmm. How do I
during
verify
class.
that?
I should say it out loud, and you should have got a note that says you're now a co-host.
How do I know that I have that?
If you look on the participants list,
Okay.
next to your name, it will say co-host.
Yeah, it does.
All right. And mainly, I'm narrating this out loud so that I remember for myself. And as we're getting started, I'd like to apologize to the students. I made a mistake as I was doing the processing to get you onboarded into our system to get to Tracemi accounts, and it's taken me longer um, to undo the damage I did with a quick script than I anticipated. should have it finished up by the time we get to the break of class to get you guys your accounts to be able to get you into the Google Classroom to be able to use other Tresemme resources. But that's completely on me, and I apologize.
Just so you all know, Mr. Campbell has been doing a lot of work in the background. So thanks, Dave, for all that work to get the class ready. Okay, so it's 9:05. We have about 14 students attending. We're expecting 19, so there's some missing there. So just to clarify, classes from now on will be Tuesday and Thursday, 9 a.m. to 11 a.m. We will have a 10-minute break in the middle, depending on how that class goes. Okay, so try to be there here on time. Dave will be taking attendance during class time. So, and attendance counts towards your final grade. So try to show up. All right. Okay, let me share something here. All right, so just to check your understanding from the last lecture, I have a quiz. So take about 5 minutes to answer this quiz. Send your answer to my email. It listed at the bottom here. So to verify a dot, conceptually there are three phases you got to go through. I would like for you to list those three phases, or if you don't remember, just write out what you think. Okay. So take 5 minutes. It's 9:07 now, so we'll come back 9:12. Send your response to my email right here, van.lee@tresemme.org. Okay. Okay, it's 9:12. Time is up. So here's the answer I've got. So the three phases, they are stimulus generation, data checking, and functional coverage. Okay, I'll look at your answers after class, and I'll let you. I'll respond, reply to your email. Okay, if I feel like I needed to explain something. But so let's go back here. Okay, go to here. Okay, so the reason I wanted to emphasize that is because this is based on my personal experience. When I started out as a verification engineer, I got to work with one of the greatest engineers in the industry. And he taught me this. So I feel like it's, and not only myself, but this is how we came out to our customers to teach our customer how to do verification. So we taught a lot of engineers, and this is not just about UVM. This is about any methodology. Back then we were doing SpecMan, but this is how we taught the engineers back then and even now. But so that's how I want to go through with you this and make sure you understand. So conceptually, there are three steps. So let's say you started out on a project, you have assigned a dot, you need to verify. So what would be the first step you need to do? So stimulus generation, right? We went through this last time. So in order to verify the dot, first thing we need to do is to have to apply some stimulus and see what the dot does. So that's number one. So that's stimulus generation. After that, we want to check if the data coming out of the dot is correct, and that's scoreboarding, data checking, right? That's phase two. And then phase three is to know when we will be done with it, right? So we need to do functional coverage, basically to verify that all the verification requirements have been met. So those are the three steps. Okay. So keep this in mind. I hope you can have this picture in your mind whenever you start on any verification project, regardless how big or how small it is. Okay. Conceptual, these are the phases you got to go through and to do it. So you may be coming into in the middle of a project. They will may make you start to do scoreboarding or functional coverage. So just to know where you are in the project helps also. Okay. Any question? Okay. Also, for people that came in late, we had a quiz this morning, so you missed the quiz. So make sure you go to class on time next time, because at the beginning of the class, I will have a quiz every time. So, okay. So any question from the last lecture? Like I said, you feel free to speak up or send message during class. All right. So we talked. So last time we talked, let's see what we talked about. We talked about, oh yeah, we need to do this first. We talked about the example test bench that we did. Okay, so a couple of things we need to verify here. So has anybody had an account, Linux account? Can you CD to this folder? No, yes?
No, we don't. We can see it.
Oh, you don't have an account yet?
Yeah,
Oh,
we don't
okay,
have.
Actually, we
okay.
just got it. We just got it. We just got an email a minute ago.
Oh, the two accounts here. One account is from Dave Campbell, Mr. Dave Campbell, about the Google Classroom. That's different. I'm talking about the Linux account on the UIT servers.
Yeah, this is the London account. We just got an email a minute ago from Tatiduk.
Oh, okay. Okay, so he's still setting up for you. Okay, well, I guess you can't look at it yet. So, but I can show you something. So once you get your account, you can CD to this home share folder, trust me, DV here. And this is the share folder between myself and all the students, okay? And we use this for the last class as well. So there'll be some items from the class. you can ignore that, but there's a folder I created called ADV for Advanced DV. Well, okay, wait, before I talk about that, let's look at this folder called Docs. Okay, so there are 3 PDFs here. I went over the System Verilog manual, which is the SV 1800-2012 here. This is the reference manual for System Verilog in case you need to reference to it, okay? There is a later version in IEEE if you want to download that, but I think this one is sufficient for what we can do in this class. And the other one is the UVM reference manual. This is version 1.1. There's a version 1.2 on Verification Academy's website as well. But this, like I said, this one is sufficient for your reference. I would recommend you signing up with Verification Academy because they have a lot of resources there. They have training videos, they have PDFs. In fact, some of the classwork for this class I downloaded from the website. So check that out. I highly recommend you to do that. All right. So the last one is the SPI PDF. This is for our project for this class. We will be working on a SPI controller. We will be verifying a SPI controller. So, but we won't get to that until the 5th session or so. So, but just keep in mind, look under that docs directory, okay? All right, so when we talk about the SPIs, I'm going to reiterate the schedule a little bit here. So initially we plan to have 4 sessions. So each session is like a Tuesday session or like Thursday session. So I was planning to have 4 sessions to go over UVM basics just to review. Some of you are disadvantaged because this is the class that we taught last semester, and some of the students in this class attended that class, so they probably know a lot more. Anyway, so we condensed that class into 4 days only, so that's very aggressive. So try to keep up with it, okay? So after those 4, right now, because we missed some time in the first session, so we're thinking of doing it after 5 sessions or so. So after that, we will start working on the SPI control project. Okay, so that's a summary there. So I created a subdirect called ADV. So let's go there. Okay, so if I list it out, there are 3 subdirectories. It's a directory called labs, and this is where you would do for the first 5 sessions. There will be labs for those, and that will be under labs. So you look under labs, there would be various test benches that you will be working on. Okay, and then there's a second directory called MuxTB. That's for Mux Test Bench, which we'll be discussing in the next few minutes. So if you look under it, there are some files. We go over that in a little bit, okay? And then the last directory called solution. This is for the lab's work that you'll be working on. If after the lab has completed, I'll provide you the solution. So in case people that couldn't get the code running, okay. So right now this is empty. So, but I'll put the solutions there once the classes start. Give me just a few seconds there. Okay, sorry about that. I got a personal phone call and I had to respond. Okay, so that's that under ADV. So this is what I need you to do. Once you get your account set up, I had this slide somewhere. Let me see. I have it somewhere. Oh, well, we'll go back to it. But this is what I need you to do. There will be a slide to ask you to do this. So what you need to do is once you get your account set up, you go to the share folder. You need to copy. I'm going to write just write it here. Copy docs to your Windows machine. Okay, and you will be viewing this PDF. I guess you can view it in Linux as well, but it's up to you. I copy them to my Windows machine so I can read the Windows PDF reader is much better. So anyway, so you need to do that in order to look at the documents. Okay, so that's number one. Number two is you need to you need to create a workspace. A workspace. Let's call it a sim or something. Okay, so you need to go to your home. You do make the sim, something like that. Okay, I'll leave it up to you. Whatever you want to name it, I call it a sim, but you can call whatever. And then you need to do copy -r/home/share folder adv labs to your sim directory. Okay, so you need to do that. And then you need to do the same with the Mux test bench. So you need to do the same with this. So under sim now, you should have two directories, labs and MuxTB. Okay. So once you're in there, because what you will be doing is you would be go to the labs. You would need to create a directory, another subdirectory called sim. And then so now this is confusing. So you need to make so you need to cd to sim, make sim. So you have two sim directories. That's bad naming. Anyway, so well, let's call it work. Okay. So let's say let's call work first. So you would be copy that's r/home/share folder adv labs to home to work. Okay, work. Okay, then you need to do the same with MuxTB. So now under work you have MuxTB and labs. Okay, because what you will have to do is you will have to do a make dir. You have to cd to work and make dir sim. Okay, and then once you're in there, you cd to sim. You're gonna have to do compile and so on, something like that. Okay, so I just want to give you a quick idea. We'll go over this once you get your account. All right, and I have a slide for that, but just keep in mind that's what you will be doing. All right, so that's that for the share folder. Also, so go to adv. Let's see if I will create okay, go to students. Okay, so here, if you have any question future when your labs or your projects, you need to ask me a question. The best way is to copy your code here. Okay, so make let's say okay, make and then copy your file to and then let's say is asking me a question. That way I can go in here, run your code and see what the issue you're seeing. Okay, that's the best way to do it based on my experience from the last class. Okay, makes sense? So go to students, create a directory for your name, and then put your code there and then send me an email, ask me questions. Okay, because I know you are very busy, so and I get busy sometimes too. So it's almost very difficult to have a live conversation. But if we have to, we can do that. Mr. Campbell can set up some Zoom session for us. But based on the last experience, the best way is to copy your source code here and then send me an email for questions. All right. So that's that. Any question? Any concerns? All right, so let's go back to the test bench. So let's go back a few slides. Okay, so well, like I said, I created a test bench called mux_tb, and in this test bench, there's a dot. The dot is this very simple mux, basically. So remember, we talked about how scalable UVM is, right? Why? Because you can take this simple mux test bench and you can expand that to make it work for a larger project, like we will be doing with the SPI controller. And then later on, if you want to expand into even a larger design, you can still do that. So that's why it's scalable. Anyway, so the reason I wanted to do a simple design is that I want you to focus on the design itself. I want you to focus on writing the test bench code instead. So I intentionally made this. That's very simple. Okay. So anyways, the mux for input mux, and the way I arrange the file organization is this. Let me go to here. It's easy to show you through this one than this guy. Okay, so if I go to this guy, if I go to mux test bench, if I do listing here, so there are, and by the way, this is the format that I'm going to enforce on you when you do the SPI controller project. I would like you to keep it like this. First of all, easy for me to debug with you. Number two is, so you have a way to organize your files. When you start working on in your real life project, you can do it your own way if you feel like that's how you want to do it. But to start out, I would like everybody to do it this way. So anyway, so under this mux_tb, there are 4 subdirectories and one script file. Okay, so this env.sh is basically to set up for your make file, set up the environment variables for you. So you look into it. That's all it does, because it's export UVM_tb dir, okay? And you need that for your makefile to work. And then I'll work with you on how to create a makefile so you can do incremental compilation, okay? And then the other one is dot. So let's look at dot, what's in there. Okay, so ignore the WB slave model here. So the design is a mux.sv. The WB slave was a wishbone slave model that I used to use for another project. So you can ignore that WB for now, okay? Just use a mux SV. So that's what it is under that, just one single file for the design. Okay, so the next one you're looking at the INF, that stands for interface. So so also you notice that I try to keep all the acronyms into 3-letter words, except for TB, but most of them are 3 letters. Anyway, so under interface, I would have 3 interface files: the clock reset, the mux in interface, and the mux out interface. Okay, so let's look at the clock reset. Also, by the way, every test bench project, I would like for you to create a separate clock reset interface. Some people would put that in the top model, which is fine. It will work too, but just to make things look clean, okay? It looks nice and clean and easy to debug. Another advantage is when you work on emulation, you would need to separate that as well. So it's no longer optional, it's required, okay? So let's look at that quickly. So CD to INF. Stop me, ask question. You don't understand, okay? I assume you understand what I'm telling you here. So I do clock reset. Okay, so all of this is just generating the clock and reset signals. Okay, and there's an additional task called do reset, and I give you a number, how many clock cycles you want to reset to assert reset. Okay, and then this is just clock generation. Y'all familiar with Verilog, so you shouldn't have any question. You shouldn't have any problem understanding this code, right? So anyway, so that's clock reset. And if you look at mux in, so there's input logic clock reset, and then you have the request signal, the output request signal, output channel, output in data. Oh, wait, is it input? I'm sorry, input request channel in data, and then an output queue full. Okay. And then mux out, okay? And then, so that's that for the INF. Okay, so the next one is sim. So this is where you actually run your simulation. Okay. There are some files I put there. This is related to Siemens tools. So I don't want to bring it up to you because, okay, so ideally, and then this has been verified, this code, the test bench code that I'm showing you should run in under Cadence tool as well, and should be running under Synopsys tool as well. Okay, so some of the stuff related to Siemens specific, I will not bring it up to the class, okay? Except maybe when we do some debug stuff. But so under sim here, the only thing you want to look into is the make file. Let me go quickly over that. Okay, so the idea, so the lot of stuff here you probably don't care, don't need. If you are not if you're not an expert or you're not fluent in Makefile, then ask me a question or just take the code as it is. But one thing I want you to know is this. So notice I create some directories, subdirectories here. So this allows me to build individual target. Okay. So I could have just one target, but the reason I do this is so that I can compile each of them separately, and this will help in our work for the SPI controller project. So later on in the SPI controller project, you will be compiling a separate agent unit agent component, a separate scoreboard component, and so on. So having the ability to build it individually like this will help in our debug. Okay, so I'll go over briefly with you now, but in the future I'll have some specific steps for you to do as part of your exercise. Okay, so for instance, to compile mux, I would have the first step I need to do is compile the mux underscore UDF. So if you look at mux UDF, basically it's all it is just compiling some UDF package. UDF stands for user defined. Okay. So you have some like enum type or some constants or some parameters you can put in here and compile it, and to be used for the rest of the test bench through imports. And at this point, let me see. I don't know if I went over the package stuff with you. Okay, so in System Verilog, there's a concept called packaging. So the way you do is you package, for instance, if you, let me see, hold off for now, okay? When I go to the next step, the test bench, we'll talk about package. That way you understand more. Anyway, so in this individual targets here allows you to build individual packages, okay? Except for the clock reset, which we list individually here. But other than that, if you notice, like on line 82 here, we build a mux-in TLM package, okay? And then in step 84, we build a mux config package. You notice all these are building packages, okay? So that's what I want to point out to you. You will be doing this when you build a SPI controller test bench. You will be doing the makefile like this, similar to this, okay? All right, so that's a makefile. So let's go to the last one under test bench. So under test bench are further subdirectories. So under AGT, that's for agent, CFG for config, CHK for check, that's scoreboarding, COV is for coverage, ENV is for environment. This is where you have the environment component and the top level component as well. TLM is for transaction level modeling. This is where your transaction is defined, your transaction class. And then TST is for test. That's what your test components is, okay? So let's look at HET first. Okay, so under HET, I'll have the mux in agent and have the mux out agent. So let's look at mux in. Mux in meaning on the input side of the mux, okay, and mux out is on the output side of that mux. So under mux in, we have, like I said, this mux in agent package. Okay, so let's look at that. Okay, so you can see, so it's already importing some other packages. Okay, so like some user-defined stuff, like here UMTB UDF package, and then there's some user-defined related specifically to the mux. It's called mux UDF package and so on. And then you can see it includes the other files that are part of this package, especially like line 16, the monitor, line 17, driver base and driver, and so on. Okay. And then there's a muxin agent.sv as well. So the idea is you declare a package with a package name, and you list out all the component files and any other packages that these files need. Okay. In this package, and then when it's used like this. If I go to let me go quickly to the environment level, cd to env. If I look at mux env package, you can see it's importing the muxin agent package here. Okay, and then in the mux env, it uses these package. Okay, I'll stop here for a minute so you can follow what I'm saying. So on line 9 here, I import the package. On line 15 here, I'm listing the files that this is my actual code for the environment here. So if I look into that, so I look into mux env, we know we import the mux in package, so we can use the mux in scoreboard. So you can see, so I define the mux in agent here, right? Mux in agent. Okay, and then I instantiate here on line 28. And similarly, I imported the mux out agent, so I can use the mux out agent, declare mux out agent here, and so on. I imported the scoreboard, I imported the coverage. Okay, so that's how it works in terms of import, packaging and importing. Any question? You'll be writing this code, so don't worry if it's still some kind of a new concept to you, but kind of a preview for you, but you will be doing this, so you will be learning it. So, okay. All right, so let's go back to here. So again, we got these different directories in this test bench, and when you build a SPI control the test bench, you will be doing the same, okay? All right, so that's that for the Mux test bench. So let's go back to our slides. Okay, so we talked about all these guys, right? Okay, now let's go back to this picture. So this is the overall UVM test bench architecture. Okay, so our dot here is a Mux design. So on one side, the input side, you got this interface called Mux in interface. On the output side, you got the Mux out interface. On the Mux in interface, you have an agent that's driving this interface, right? So if you go back to that picture that we talked about, the three-phase picture, this is your stimulus generation here, right? Okay. And then on phase 2, which is data checking, you monitoring the output, you send it back to the scoreboard. So you got reference data coming into the scoreboard this way, and you got actual data coming back to the scoreboard this way. So this scoreboard is checking the data. Okay. And then for coverage, you send the reference data to coverage and the output data coverage, and whatever you want to cover in your verification requirement, you would provide a similar function of coverage for it. Okay. And we'll go over that when we talk about verification planning and so on. All right. And so in order to run these UVM tests here, we need to create an environments component that encloses the agents and the scoreboard and the coverage. Know that when doing our phase one, we don't need these two guys, the scoreboard and coverage. Okay, we just need the environment, the Muxin agent, in order to run our test, supplying stimulus to the DOT. Right. Only when we do the phase two, then we need to include the MuxOut agent and the scoreboard. Okay, and then phase three, we need this guy. And then above that, you have the test case, you have to have the test component. This is why you create a test case. The test component will instantiate the environment and so on. Okay, and then we'll dive into the details later. Okay. Okay, so that's the overall scheme. So let's go back and look at this one more time, just to see. So we look at the MUX env source file. So if you look at this, you can see that they declare Muxin agent, MuxOut agent, Muxin scoreboard, Muxin coverage, exactly like this guy, right? You see the environment here, instantiate Muxin agent, MuxOut agent, scoreboard, and coverage. Now, for phase one, you don't need line 14 through 19, right? You only need line 13 to do phase one. So keep in mind with this implementing just phase one only allows you to just run simulation to verify the status of the DOT, which seems would seem trivial, but it's very important in your project, because when you start out a project, sometimes the design is very raw, still a lot of bugs, a lot of issue. So being able to compile the DOT and run some simulation and generate some vectors into the design is very helpful for the project. Okay, so keep that in mind. All right, so we talked about ENV, so let's go to test. Okay. So on the test, there's several tests I have here, but let's look at the demo test. Okay, so let's go back here. So we just talked about environment, right? In order to run a test case, we need a test component. So this is the outer layer here. Okay, so here, this is our test demo, Mux demo test. Okay, this extends from a Mux based test, which does some basic stuff. We'll go over that later, but let's look at Mux based test just to show you what it is. So you can see it extends from UVM test. Okay, this is a base class in UVM for test cases. So, and it does a bunch of it set up the environment in this test case. So you can see here, so test it needs to instantiate the environment. Okay, so this is what it does here on line 34. It declares the environment, line 15 and 16, type, def, MuxInv, and so on. And then it instantiate on line 34 here. So this is where you instantiate an environment. And the reason we're doing a base test instead of doing a demo test, it's okay if we do in a demo test, but guess what? If you do a second test case, which is, let's say, error inject test. So I look at error inject test. Okay, if I want to do it here, then I have to create the environment myself over here. So instead, I extend the base test. So all the test cases would extend from base test, which does all the basic stuff for you. So get the idea. Okay, so base test does all the basic stuff, basic configuration, basic setup. One of them is instantiate the environment level and environment component. Okay, I hope you get that idea. And you do the same with other scenario. Let's say a sequence, for instance, you want to create a base sequence. So and the base sequence does all the basic stuff like reset the DOT and so on. This way, you don't have to repeat the same code in a new sequence, or in this case, in a new test case. Since you do all the basic stuff in the base test, all you do is just extend it from the base test. And that does all the basic stuff for you. Okay. All right. So that's that for tests. Okay. So that's the overall scheme right here. So let's do some quick summary. So for phase one, which is stimulus generation, you just need the Muxin agent connected to the DUT via the interface, the input interface. You instantiate with the env component, and then the test component will instantiate the env component, and so on. So you got a test running already with phase one, okay? And you got some stimulus coming to the DUT. The next step is you want to verify the DUT. You need to verify, do some data checking. So you got to add in a MuxOut agent to monitor the output side, and install a scoreboard to do the data checking, and then so on, moving on to phase three, doing coverage. Okay, so you get the idea? Any question? Okay, so let's say this DUT is a different DUT. It's not a MUX. Also notice here, even though I put in Muxin agent and so on, you notice that if we're doing it correctly, this picture can be applied to a different design as well, right? All you need to do verify is to change is what? The interface here, right? And the transaction that you're sending into the MUX. Okay, so for instance, let's say this is a USB device, right? And you want to send read-write command into it. You can do read-write through this Muxin agent, which basically has a component called the driver, which acts like a BFM basically, right? Just drive the USB in transaction into the DUT. Now, if it's for let's say instead of USB, let's say SPI, right? It's the same configuration here, right? You can see that all this stuff can be reused for a different interface. Okay. All right, let's go to the next slide. Okay, so here we go, verification planning. So earlier, yes, last class, we talked about what were the steps in verifying a DUT. And somebody said verification planning. That's right on the money. Okay, that's the first thing you have to do. So I used to do consulting work for companies in the U.S. So when we came into a customer, we look at the situation. The first thing we did was do verification planning, right? We got to look at the design. We got to propose how long it's going to take. We got to propose what's going to be done and so on. So very important in planning, right? And you're going to do the same when you start working out in the work environment there. And then for the SPICE project, we're going to do the same with verification planning. So what are the steps in this verification planning? First is you got to review the design specification, right? You got to understand what the design is about. Note that here we do not talk about logic design yet. We don't talk about RTL. Okay, so a lot of situations you deal with RTL before you even get the design specification because the project is so urgent. They haven't finalized on the spec yet. So keep that in mind. But once the spec is in place, everything has to follow the spec. So review the design specification, understand what's required, and so on. So from that specification, you extract a list of verification requirements. For instance, with the SPI device, we got some parallel data coming in and some serial data coming out. What would be the first requirement? The serial data has to match with parallel data, right? So something like that. So we got to look at the design. We got to generate a list of verification requirements. So each of these design requirements must be covered by at least one item in the list of verification requirements. Okay, that's I'm on item number 3 here. So you got a design spec, and you got a list of verification requirements, and you got to verify that every design requirement must be covered by at least one item in the list verification requirements. And then you would review the verification requirements with all parties involved, including verification engineers, design engineers, and software engineers, sometimes validation engineer as well, okay, to make sure your list is complete. Okay, there's a saying in the industry is your verification is as good as your list, which is very true, right? Because if your list doesn't cover everything and nobody knows that you are missing it, then you're missing a big part of it, right? So keep that in mind. Your verification is just as good as your verification requirement. Any question? All right, so let's see. So let's talk about now, we just talked about verification planning. Once we're done with the review process, we've got a list of items we need to cover. The next step would be to build a test bench to do it, right? So note this though. I mean, once you know the requirements, when you build a test bench, you got to build it so that it would optimizing the satisfying of the requirements, right? So that's important, right? Okay, so building a human test bench, again, we're going to go through 3 phases. Okay, so phase 1, stimulus generation. What do we need? We need to create the interface modules. Okay, so I'm going back here. I'm going to look at this again. I'm going to go this over until you get really sick of it. Okay. All right, so here we need to do this. Okay, so you need to create the interface modules. That means for this mux test bench, for instance, I need to create a clock reset interface, the mux in interface, and the mux out interface. Okay, and then I need to create a top.sv. Okay, and we'll look at the top.sv next, but for now, this is your top level module. This is for Verilog people, this is your top module, okay? There is a slight distinction between this and the normal Verilog top. We will cover that in the next few slides. And the next step is to create a TLM transaction class. Okay, so let's look at this guy. Let's go back, look at this picture. Okay, so we talked about generating stimulus into the DUT here, but we haven't talked about how. Where is the data coming from, right? It's not shown in this picture. Well, it's kind of implied. It kind of gives you the overall connection of the components in the test bench. It doesn't really provide you the details, but yes, it's missing it's missing that where the data is coming in. So let's go here. So that's what this transaction class is. I'm on line 3, create TLM transaction class. So let's look at that in the code. If you're losing me, let me know. Okay, stop me. Well, that's our 9:55 alarm. So let's take 10-minute break. Okay, be back around 10:05.
And Van,
Yes.
I've got 2 students that I haven't seen in the participants list yet that I just want to make sure. Dung Hwan Dun, I know that I'm mispronouncing that, and Cao Yip Yui. Are they here? And let me share my screen so that you can see. These are the students that we'd like to
You're missing those 2?
I'm missing those 2, and we need them to speak up, but I'll start the timer for the break.
Okay. Okay, so Dương Hoàng Tuấn, and Cao Nhất Duy, please raise your hand if you are here in class. Or if somebody knows where they are and so on, you can speak up as well. Okay, I guess they're not here, Dave.
Right. I'll start the timer.
Okay.
And see everybody in 10 minutes.
Okay, thanks. Okay, I'm back. Let's see, I have to share again. Okay, any questions so far? Let's see, let's go to this guy. All right, so we were talking about building a test bench. So let's go back here a little bit, go back to the verification planning. So I think it's important to emphasize this, the fact that you must complete this step before you even start building your test bench. In most cases, some cases, like I said, when the spec is not ready, then you gotta do it in a different order. But if you can, always do your verification planning before everything else. Finalize it before you even start writing your test bench code. Okay, because it's important you do this. Okay, so we've talked to TLM transition class, but let's stop a little bit. We actually were supposed to do a lab. So let's see. But it's because you don't have a Linux account yet, so I'll waive this lab, but I want to go over that with you. So your first lab is working on the interface block. Okay, so in this, so one thing, so all the project files in this labs are one single file. So earlier I was telling you about doing subdirectories and so on. but to keep things simple, just to get my point across, I do it differently. Okay, so for all the lab work, lab components, it's only one file for every lab. Okay, so we breaking the rule a bit here just to get my point across. So your task was to generate a clock with the period or 20 nanosecond here in the clock interface. This should be simple for you with Verilog experience. Okay, and then in this test case, all it is just a simple test. Okay, and so let's go over these components. First of all, the clock interface. Inside a clock reset, now we don't have reset because this is a simple interface. So we're going to do just the clock interface. So you can see the interface and end interface block here. And then we got the environment level. All it does is just go through build phase and connect phase, which is nothing because this is a simple test. Okay, but you need the environment in order to do the test. And then you create a demo test, extend from UVM test on line 53 here. So, and then on line 58, we instantiate the environment, we declare the environment level, and then we instantiate on 67. Okay, and then the standard run phase task is on line 70 through 74. I'll go over each of them next. I just want to give you a quick overall overview. Okay, so in here you got phase raise objection and drop objection and so on, and then the module top, because this is your top level right here. So remember earlier I was telling you there's a slight difference between your normal Verilog top and the UVM module top here. Is where you do the run test here. Okay, so in your initial begin here, you're supposed to do a use UVM config DB set to put that in the resource database, and then you run test, demo test. So let's go first thing first. Let's look at the solution. Okay. So in the solution, so this is where the clock generation is. Okay, line 12 through 14. Okay. Okay, and then on line 84. So let's go over this first. So in UVM, there is a resource database that you can share among the UVM components, okay? And the way you put an item into that resource database is through the function called UVM config DB set. And then this is a syntax. Okay, remember I told you in the last class, I don't want you to memorize this code. You can look it up if you need to, okay? But you need to know that you need to put that in the resource database at this step, okay? But you don't have to memorize the actual code, okay? Get the point? Okay, so the way you do that is you put the clock interface in the resource database with the null and star here. Basically, the first two parameters allows you to look up in a specific component and specific instance. In most cases, you don't really need, so I don't even bother putting in something different than this for now. So stick with this format for now. But the next field, this is the name of the interface, and you have to be specific here, okay? Because even this is case sensitive as well, all right? So when you do the UVM config DB get, you will have to specify this parameter, okay? And then you, of course, you put the interface handle over here. Okay, so this is how on line 84, this is how you put that in the resource database. Okay, so why? Because later on, not in this particular lab, but in future labs, you would have to call UVM config DB get to extract the handle of this interface in order to access the signals. Okay, when we get there, we'll talk about how we do that. All right, so let's go over some overall UVM format here. So you notice on line, so let's pick the demo test. Oh wait, one more time before I forget. So on line 85, you do run test here. So what the UVM engine does, the simulator does is it goes in and look for the test for demo test to run it. Okay, so So on line 77, when you start running Tom, it will do all the normal processing of the code here, right? But when you get to 85, this is where it knows it's time to go into the test bench side to elaborate the test bench and start running it. So elaboration means you would go through the build phase. Remember we're talking about UVM phases. Let's go here. Let's go back here. See where it is. Wait, we're not there yet. Okay. Okay, yeah, so here, remember we talked about phases, so let's go back here. So when we do run test, there are two cases. First is you specify the test name. In this case, it will run demo test, which is this, on line 49, you specify the demo test. If you don't have the demo test here, let's say you just do run test. So if you just have this instead, then it will run a test specified by a directive called UVM test name. Okay. So hold off on that. We'll go back to this one later. Okay. So for now, because we specified demo test, it will run demo test here. Without the demo test here, it will run a test based on the UVM test name directive specified at the command line. Okay, which is in your makefile. I'll point it out next time. All right. Okay, so let's see. All right, so we talk about a class. Okay, so we talk about UVM classes component as opposed to transient object. So we want to focus on the UVM component side. So demo test, UVM test is a component, right? So we extend from it. So the format is this. So you extend from UVM test, and if we have like a base test, then we would have like base test, extend UVM test, and then demo test, extends base test, and so on, right? Which we went over that last time. Anyway, so the format is this: class extend UVM test, line 51, UVM component utils, demo test. This basically register this. So there's a big class in the UVM called factory. Okay, so it keeps track of all the class names, class types, and so on, because this allows it to do overriding later on and instantiation and as well. So this is almost like a requirement that you have to put it here. Okay, so the format is UVM component for an object will be UVM object. Okay. And then if you have parameters, it will be UVM component params. And when we get that, I'll point it out. But you have to have this line on line 51 here. It tells you the demo test is a component and it is going to register with the factory. You need that. Okay. So what I'm saying is later on when you build other components like agent component, you have to have that line as well. Okay. And then you have to have a function new. Okay. Let's see, we have to have the function new in this format. Okay, what I do, this is for my personal preference. I introduce a string called my name. So when I instantiate the component, I specify the name. So I copy my name. Well, this should be this. Well, this will work as well, but this can be this. Okay, so either way, but I would prefer this. Okay, so I put the name into my name. So later on in my code, I refer my name like on line 68 here. That will print out the instance name of demo test. Okay, so anyway, so you will need a function new implement this way. So again, so this is like a template code. So for let's say for your agent, you need the same thing. It's the same syntax here. Okay, so you can just copy paste. And then you need a build phase or So depend on your implementation. Sometimes you need a build phase. Sometimes you need you don't. Sometimes you need a connect phase, and so on. So when you need it, you just declare it. Okay. So in this case, I declare I need the build phase. Why? Because I need to instantiate the environment. Okay, which is done in the build phase. Remember that. All right. So the same way, similarly. So if I go to environment, so let's go up here. I go to the environment. Do I need a build phase? I don't need a build phase, you can see. So the code 34 through 40 can be deleted. Or even, I don't even need a run phase for this particular test. Okay. So anyway, so we go back to demo test. So I need the build phase, so I put it here, instantiate env0 here, right? Okay. And then on line 66, so because it's a component, so what? So it has a run phase. Okay, so let's go back here. It executes these phases, right? So it will execute run phase, and in run phase, you have to have this line 67. So in the way UVM starts and finishes the simulation is based on the objection count. So when you raise objection, it will increment the count by 1, and when you drop objection, it decrements by 1. So on line 69, when it decrements it and it's 0, its simulation is complete. It's done. Okay, so that's how you terminate simulation. You can extend this in other components, so you can do the raise objection. Sometimes you need to run the code some more before you terminate simulation. So anyways, it implements implementation specific. All right. So that's run phase for demo test. So like I said, you have these phases you got to deal with. So for this particular case, you only need the build phase basically, okay, and the run phase to start and stop simulation. Okay, so let's go back here on line 85. When you do run test, demo test like this, you will run the demo test only. So for some test benches, you don't want that, right? Because you want to be able to specify which test to run, because when you run the test design, there are lots and lots of test cases you need to run. So this line 85 is almost like only works for this particular case, right? And the way you do that is, let's go to the makefile. Let's see, let's go here. Okay, let's search for that. Yeah, so you see, in a run test here, VOP run on line 102, you specify the plus UVM underscore test name. This is how you specify which test to run. Okay, so imagine you have 10 tests written, right? And when you build a test bench, it builds all 10 tests. Okay, and in order to run one test, you specify what test name to run. So imagine you run a regression with 10 tests. You're gonna have 10 commands, right? Each command has different test name. Okay, so that's how you specify the test name other than line 85 here. Okay, understand? All right. Any question?
So can you explain about line 56 about UVM component parent and super dot new name parent? What is this?
Oh, okay. Okay, sure. So let's say line 61. So you extend from UVM test. So this is you probably don't need that even, right? So this is useful when you have the base test. So let's say you have a well, let's go here. Let's look at this example. Good question though. CD test bench, CD test. We looked at this earlier, I think. Yeah, so we look at you look at Mux demo test. Okay. So let's look at base test. The dice. Okay, so if you look at it, so let's look at the build phase, and other phases are similar. Okay, but so we extend from the base test, we extend from UVM test, and then we have build phase, and in the build phase, we instantiate line env handle here on line 34. We instantiate the environment component. Okay, so in the build phase of the base test, we instantiate the environment component, right? So let's look at the demo test. Okay, so in the build phase, in order to do that, we're going to call super that build phase. So what it does is it calls the build phase in the Mux base test. Okay, and that's where you instantiate the environment. Okay, so by doing that, you don't have to rewrite the code. All you do is just call the super that build phase, and that will do that for you in the base test. Let's say if you do the error test, VI error inject test. If you look at the build phase, it's also the super that build here, right? On line 24. So that's how super that build or super that run do for you. Does that answer the question?
Yeah, thank you.
Okay. Yeah. So good question, because you would almost likely will need to do that for your test case as well as for your sequences later on. Okay. Okay. Let's see. So we talked about verification planning. Always do that before you even start writing your test bench code. Okay, so we assume we did the interface correctly. So now we go on to do the top.sv. Let's see. Well, let's just look at it. Okay. Okay, so here's an example code in the Mux test bench. So you notice that I declare the interface here. Okay, 23 through 25. The three interfaces, and then notice how I put in the resource database on line 30 through 32. Okay, so that's what you do in the top module, basically, right? And then of course line 27 is where you instantiate that. For Verilog people other than these lines, it should be familiar with you already. Okay, so again, run test, I don't specify the name because I want to be able to select at runtime. Okay, so that's that for the top module. So you need to create the top SV. I'm leaving this out because these are the steps you will have to do for your SPI controller test bench. These are steps you would have to go through. All right. So next step is create a TLM transaction class. So let's look at the TLM stuff. It's too bad you don't have a code yet, but once you get a code, I would like for you to review it just to be familiar with it. Okay, you don't have to memorize it, but just to know where things are. Okay, so let's look at that again. If you look at the Mux package, so oh, also by the way, on any package you have to have line 8 and line 12. Okay, always. But that's UVM stuff. You have to have those. 9 and 10 is optional. Sometimes you need, sometimes you don't. But if you look at it, so it has two files, the define file and the Mux and TLM. So let's look at Mux and TLM. So in the future, in the other components, if you need to be able to use this TLM package, you have to import it, right? So you look at the Mux and TLM here. So because it's a Mux, I need to be able to look at. You need to be able to send the data as well as a channel, right? And I want to be able to reset the Mux as well. So these are the signals I need, right? For the SPI controller, you will need something else, right? So I'll leave it up to you to think about later on. But for the MUX, so the transaction includes, of course, you got the name and so on. And again, on line 8 here, it's a UVM sequence item is an object, so you declare as a UVM object. The other one we declare as UVM component, right? So this one we declare UVM object, okay, and then the name. Like I said, you have to have line 8. Okay, so line 12, I declare data. Well, Muxin data underscore T is defined in the other UDF. That's why I reused it here. But ran here means random. So what it means is you can randomize these fields inside this class. Okay. And let's see. So you follow with me so far why I need data and channel and to reset? Okay, imagine you want to send a packet here. Let's go to the test bench. Okay, I want to be able to send a transaction to the DOT, right? For the MUX particularly, I would need what data I want to send, what channel I want to turn on. And then also I want to be able to reset it. So that's why I have these fields here, right? What if I want to have like, I want to wait for a number of clocks. Then you would have to have a bit to wait as well, right? So when I set that to 1, you want to call the function. So when you send a transaction class, I don't show you here, but let's go back to this one. Okay. Yeah, so here I want to send a transaction to the driver, right? Right here. So I want to be able to tell the driver what I want to do, basically. So whatever capabilities you want to have, you put in a transaction. In this case, I want to be able to send data and channel as well as want to reset it, right? Okay, so what if I want to just wait? I want you to wait for like 5 clocks. Then what do? So I want to introduce another bit here. I would call it bit to wait, something like that, right? So when the transaction goes to this BFM, it sees that to wait is set. Then it will wait for a number of clocks specified in whatever field in the transaction, right? Follow me? Okay, so in this case, we just need these 3. So we have these 3. So when this transaction comes in, I'll look at to reset first, right? If to reset is 1, then I want to reset the dot for a number of clocks. Otherwise, I would send the transaction to, I say, turn on this channel with this data. So that's what transaction does. The transaction class does, okay? So again, line 8 is required. Line 16 through 19 are required. Okay, so let's talk about do copy and do compare and so on. Okay, so this is a little bit long, but I'll keep it short. So basically, when you do a transaction, an object that copy, it will copy so if I want to do something like this, for instance, let me just write it here. If I want to do object, I want to do destination object that copy source object. Okay, if I want to do something like that, then what it would do is it would take the source object and copy all the fields in the source object into the destination object. So follow me. So that's what do copy does. Okay, and this is a default when you call copy, and because UVM sequence item is an extension of UVM object, it will call do copy by default. And when you call do copy, this virtual function do copy will take over and do the copy for you. All right. Notice it calls super.do copy as well, because there may be other fields in this guy that need to be copied as well, right? You following with me on this do copy thing? Okay, so similarly, when you do compare, it will compare the fields that you specified here. In this case, I want to specify the channel and the data. Okay. See, when you call compare, then it will return 1 or 0, right? So if it matches, it return 1. Otherwise, it returns 0. Okay. So this is for do compare, and then we can skip comp for now. Comp doesn't apply in this case. Okay, so do print. So we'll talk about do print. So again, similarly, when you do object.print, it will call this do print function. Okay, and then it will print out the data and channel like we specify here in a formatted form. Okay, and then the last one is convert to string. I'll go over this when we get to the scoreboarding, because in this test bench we use something called a built-in comparator. So that built-in comparator requires convert to string to be implemented. So we put it in here. Okay, so basically all it is just formatted text, channel, and data, and so on. All right. Okay, so that's that. So just keep in mind, what I want you to know is because we extend from UVM sequence item, which extends from UVM object. Well, let's look at that. Let's look at this guy. Okay, so if I go to object, or actually sequence item. Okay, so UVM object here. So you see it does do print, do copy, and so on. So if you look at UVM sequence item, UVM sequence item, you can see it extends from UVM object here. Okay. Okay, so again, if you have some time, go through this guide, try to understand what it does internally. Okay, so because we extend from UVM sequence item here, all these functions must be implemented. Okay, if you don't implement it, it won't do anything basically. So if you put it in, if you don't do compare here, when you put it in the default, the built-in comparator, it will not call this, and so it would never do compare. So you would actually pass the checking, even though you're actually not checking. Okay, so keep that in mind. All right. So so besides doing the built-in compare, you can do your own compare, which we will do in the SPI controller. Okay. All right. So that's that. Let's see. So let's summarize a little bit. So no. So basically in the transaction class, so let's go back here. Gotta go back and forth on this guy. Okay, so when you create a transaction class, you need to what? You need to specify the fields that you need for the driver to act upon, right? So in the MUX test bench, we need the channel and data as well as to reset. So we create those fields, those 3 fields. For the SPI controller, we might need something else. We might still need to reset, but we might need like parallel data or whatever, right? Okay. So anyway, create a transaction class is the next step. After that, create a master agent. Okay. So for our test bench, the MUX test bench, there's only one interface. So there's only one input interface. So we only need one agent. Okay, so the way the agent works in UVM, so this is for people that are not familiar with UVM, I'll go over this. Okay, so let's see, do I have a slide for this? Oh, okay, yeah, here we go. Master agent. So for non-UVM people, the way the agent works, we call it an agent. Note this, okay? remember we call an agent here. This in case we call this a Muxin agent, but what if it's a spy controller? Then it would be a spy agent, right? So it would be the same concept, okay? But only just slightly. The difference is when you actually drive the transaction on the bus is where it's different. Otherwise, it's the same. So it's the same in terms of the structure, internal structure of the agent, okay? So here we go. So inside the agent, you would need the master agent. Okay, master agent means you're driving data into the DOT. Okay. Slave agent means when you monitor the output of the DOT. All right. So make the distinction there. So in a master agent, you always have to have two basic components called sequencer and driver. Okay, a sequencer is also a UVM component. A driver is also a UVM component, meaning it will go through all the phase execution, right? Okay, why we need a sequencer? Because first of all, let's see. Okay, let's look at this. Okay, so the way you remember we talked about stimulus generation, we generate data to drive into the DOT. So this is how you do it. You use a sequence to drive data to drive a transaction. Remember, we just talked about transaction class. A sequence drives a transaction class into the sequencer. A sequencer would store this transaction and until the driver pulls it, okay, and pulls it from the internal buffer. So the driver would just sit there and wait for, or do you have a packet for me? Do you have a packet for me? And so on until the sequencer has one. Then it gets it and it does its thing. Okay, so the transaction is to reset the DOT. It will reset the DOT and so on. Okay, so that's a flow, the flow of the data. Sequence will send transaction classes into sequencer, and then the driver will pull the transaction out of the sequencer. A sequencer can implement a random selection as well. So in theory, you can have multiple sequences sending data into the sequencer. But for most typical application, you only need one sequencer and one sequence. But a sequencer can do more than that, okay? So anyway, I won't discuss the multi-sequence into a one sequencer. I'll leave it up to you. In my experience, I've never used more than one sequence per sequencer anyway. So, but I'll leave it up to you. I want to point that out though, so you know there is a distinction there. All right. Okay, so let's talk about sequence a little bit. We have a separate slide for that, but a sequence is what? It's a series of transaction basically. So it's got a series of transaction objects that need to send into the sequencer. And then the sequencer stores those transactions and the driver will pull it out. And there's a mechanism to do that, built-in UVM mechanism for that, okay? So again, here, I don't show the sequences, but the sequence sends item into sequencer and the driver pulls it out, send it to the interface, okay? So let's go back here. Okay, so we talked about master agent, sequencer, and driver. So I just kind of explained the overall structure of that. Okay, and then we'll talk about analysis ports next. But let's look at the code. Any questions so far? Still puzzle? Okay, so let's look at the oh. Okay, so let's look at the agent, AGT. Okay, so there are two agents, Muxin and Muxout. So let's look at Muxin. So in this case, Muxin is the master agent, right? So we look at the Muxin agent. Okay, so you can see the Muxin agent declares a sequencer and a driver. It's also a monitor. In this case, it needs a monitor as well. But the two main parts are sequencer and driver. Know that for phase one execution, we only need sequencer and driver, right? We don't care about monitor yet for phase one. And then there are two ports. Let's see, we'll talk about ports after this, okay? But let's go over the sequencer and driver first. I want you to understand what the mechanism here. So I instantiated in on line 33 and 34. Forget about the other stuff for now, okay, guys? Just look at the sequencer and driver. So we declare the sequencer here, up here. Again, the agent go to, okay, yeah, I'll jump back a little bit. So remember this agent is parameterized, right? It's extended from agent. So remember back then we only do component utils, but now we have to do component param utils, okay? So this is the format. Again, just remember the format. Make the distinction. You have non-parameterized and parameterized component as well as object now, right? So you have to look at three different formats. Okay, so we type that with up here on line 11 and 13, and then we declare on line 17 and 18. And when we instantiate on line 33 and 34. Follow me so far. You okay up to this point? All right, so we have instantiate them. Now we have them, right? So the way so we talked about connecting them, right? So this is how you connect them. Okay, so in the driver component, there's a port called sequence item port. So you connect that to the sequencer sequence item export. Okay, so this code is almost like by default. So there's nothing else to do. You have to implement this and know that it's implemented in the connect phase. Why? Because you have to wait until it's done in the build phase. Remember, we're talking about build phase first, top down, and connect phase bottom up. So once the UVM engine the simulator goes through the build phase, the next phase is connect. So at connect phase, we know the driver and the sequence have already been built, right? So now all the ports are available. That's why we do this in the connect phase, okay? You can even do this in the elaboration phase if you want to, although most people do it connect phase. And that's all. There are times when it may be sensitive as well. But so keep in mind, we have to do it in connect phase. You can't do it in build phase, okay? All right, so that's that for the agent. Any question? So now at this point, you declare the driver, you declare the sequencer, and you connect them up. Okay, so let's go back to the slides. Let's go back to the slide. So at this point, you got these two guys connected. Okay, the agent is inside the agent. Okay, so again, the driver, what it does is it drives the transaction into the dot, right? Okay, so there we got that. Now we go to okay, so let me see what I do next. Okay, maybe we just look at the driver. So we talk about connecting them, but we haven't talked about how to extract data from it, right? So let's look at that quickly. I'm jumping ahead here, but I think that'll be okay. So let's look at the MUX-in driver. Okay, so the way you do this is this. Okay, so the driver, when the simulator runs, it runs the build phase, connect phase, elaboration phase, and so on. And the next phase is run phase. This is when you actually run simulation here, meaning we would extend time, right? There's no longer build phase and connect phase. Elaboration phase are done in 0 time, no time consuming. But run phase, you start consuming time here. So when you call run, and also remember, I told you run phase runs in parallel. That means run phase in the driver and run phase in sequences all run in parallel. Okay, so I hope you understand the scheduling concept in the simulation, in the simulator. Okay, Anyway, so on line 37, when you run face, you report some info. And then, okay, line 34. Okay, remember we talked about UVM config DB set. So on 34, we actually do the UVM config DB get. Now you want to get a handle to the clock reset interface. Okay, so you declared on line 12 the clock reset. Oh, I'm sorry, line 13, the clock reset interface. You have to declare virtual interface. Okay, and then you extract the handle, assign that handle from the resource database into that handle via the UVM config DB get function call. Okay. Okay, follow me with that. So at online, if there's an error, then you issue an error on 35. Otherwise, after line 36, you already have a handle to the clock reset interface. Okay. And then instead of doing the code there, what I do is I call a task called get and drive. Okay, so I go to get and drive. So all of these is just a forever loop, right? Okay, so it's a forever loop, and it start the loop with what? A call to the sequencer. Okay, remember we connect the driver sequence item port into the sequencer. So to extract the data, that's what you do on line 51. You extract the packet for a transaction from the sequencer. So that's how you do on line 51, and it is a blocking call. So if the sequencer doesn't have anything, this task just sits there and wait. Okay. And then once you get the transaction, first thing you want to check if it's null. If it's not null, then we'll go on. We'll do the next check. If to reset is 1, remember the transaction has a field called to reset. If it is 1, then I call clock reset VIF dot do reset for 5 clock cycles. Okay, so let's look at that. Okay, so I call do reset via the clock handle, the clock reset handle, like this. Okay, as a reset for 5 clocks. Haha, I do it wrong here. It should be reset length. Anyway. Okay, so you get with me so far? Now, if do reset is 0, then I'll do something I call send data. Okay, and then I go to the actual code to send data. I'll let you review that code, but all it does is the send data here, and all it does is send the data to the channel, right? But in the SPI interface, you will do something totally different. All right. But note, the only difference between this and the SPI interface is what? Is this task here, right here, right? The rest of the code should be similar. Keep that in mind, okay? So when I ask you to build a SPI driver, you probably want to reuse most of this code, except for this code right here. Then you have to implement the SPI specific implementation. Okay, so that's that for sequencer and driver. Any questions so far? Like I said, go back and once you get your account, your Linux account, go back and look at the test bench code. Make sure you understand how the data is being sent across from one component to another, how the driver gets the packet from the sequencer and so on. Okay. All right, the next step is analysis ports. Okay, so let me see if I have a slide for that. Okay, analysis port. Okay, so in UVM they have a pair of ports. So basically a sending port and then a receiving port, right? And they implement a little I would say awkward is when you send the port, they call the port the name the port two names. So there are 2 types. So you have the This is a little different than what I've had. Okay, so I'm getting ahead of myself here. Okay, so first of all, there are the two types of ports: analysis port or the other one they call, I can't remember what it's called, but it's a one-to-one port connection. Okay, give me a second here. Let me see. Let's see here. Okay, so there are two types of ports. The first one is called UVM blocking put export and put port. And then analysis port. Okay, the first one on line 52 here, this type of port is a one-to-one. The on line 53 analysis port is a one-to-many connection. Okay, so we're only going to focus on analysis port. Okay, for this project, but I want to mention to you there is a different type of port as well, which is the blocking put export. Okay, and then blocking put implementation. Anyway, so research on that if you're interested, but we're going to focus on UVM analysis port only. Okay. All right, so let's go back here. So UVM analysis port here implements a write function, right, that facilitates transfer of transaction from the monitor to coverage collector or scoreboard. So look at this. Whoops. Look at this guy, this picture. I'm sorry, I don't have anything better to show you. Got to go back and forth on the slides here. Okay, so we show this picture. I show you this picture, but I didn't show you what actually happening here. So right here, there would be a port, okay, analysis port, UVM analysis port, and that will be connected to this guy we call a UVM analysis export or implementation. Okay, so the way it works is when this guy has a port, let me call it AP. If I do AP.write, it will send the data to here, and this guy will have to implement the write function. Okay, that's how it works. So let's see. Actually, let me see. Sorry, just a second here, guys. Let me see where we are. I want to make sure I'm not jumping ahead. Driver ports. Okay, yeah, sorry. I wanted to check and make sure I didn't jump too far ahead of the labs. All right, so let me see, how do I explain this port stuff with you? Let's look at so this is I think this is the best way to explain it. So this is a TLM ports lab that you will be doing. So the way you declare the source, so the sender basically is, you name it analysis port, and the packet type, in this case, a TPL TLM, it's a transaction type TPL underscore TLM, and the name of the port is AP for analysis port. And then remember, this is a producer, so it's sending the data, okay? And then on the consumer side, you will call it a UVM analysis implementation. IMP stands for implement, okay? And then the way you do is you declare the transaction type, also the name of the receiver, and the name of the port, okay? And the way you connect it is this. And remember, we're talking about implementing the write function. So on line 91, you declare the receiving port, and then on line 105 is implement the write function. So whenever the AP port sends the data to the IMP port, the write function gets invoked, right? but the way you connect it is through environment level. Okay, so I got a producer P0 and consumer C0. Let me see how to connect. Oh, I'm showing you the I think I'm jumping ahead. You're supposed to do the lab first before I even. Okay, so we're gonna hold off on that. I don't want to jump ahead with this. I want you to do the lab first before we can talk about it. So the analysis part, just keep in mind that there's a pair connection that's on the sending side and the receiving side, and there's a mechanism to connect them. I'll go over that when we get to the lab. Okay, so you need to do the lab about the analysis port before we can go there. So think about driver sequencer and analysis port as part of the master agents for now. Okay, like I said, we'll go back to the ports later. This is a very complicated subject as well, so I have a separate test case for it. Okay, so let's jump to sequence for now. Okay, so we talked briefly about sequences. So now let's go to the code here. So under the master agent, there's a sequence directory. So again, this is all. Oh boy, we are a little slow. Okay, it's 11 o'clock, so I can't keep you anymore. We will come back to. We'll go back talk about sequences next time. Any questions so far? Again, try to show up on time. Next time I will start out with a quiz. I would like everybody to do the quiz just to check your understanding. If you have any issue, anything you don't know, send me email, ask me a question during class, or send me email. I'll try to explain it. Okay, so make sure you understand all the stuff that I've covered, because like I said, the condensed 4 or 5 day session, 4 or 5 day part here is very aggressive. So try to give a lot of information to you in a short period of time. So it requires you some extra work there. So work on it, ask me question, email me, whatever, and I'll try to explain. But after this, I expect you all to understand and be able to write some code, okay? So I will see you on Thursday at 9 o'clock. Bye now.
Van, I got one of the students came in late. I marked that on the attendance sheet, and I got intermittent captures of the participants. I'll go back and verify that the other student didn't come in late. And,
Okay,
reach out
okay.
to him.
Yeah, maybe let's make it so if like 20 minutes late, then make it no attendance, something like that. I'll leave it up to you. I'll leave it up to you, Dave.
Yeah,
You
I'll
make the
note
call.
that. And then I want to make sure that we've got this on our radar. I'm going to be getting on an airplane right as class starts next Tuesday. So we're going to need to make sure that we've got support for you to get into the class and making sure that
Oh,
the
okay,
class
yeah,
goes
yeah. Let's maybe we'll find some time to meet up to talk about that.
Sounds great. And my
Yeah,
schedule
something.
is really flexible, so let me know when you want to meet.
Okay. Someone asked if I assume you're talking about the slides. Let me talk to Professor Tae-sung and see if this is. Let me talk to. Okay, let me see. Let me talk to Tae-sung, see how we can do that. We can issue the slides to y'all. Okay.
All
All
right.
right. Thank you all.
Yeah. So I missed the previous class, so can I ask if I can have record of it?
Oh,
So right now,
Dave.
Traceame does not allow the files because we've got a question about some proprietary material with the last class. Let's check with Phil to make sure that we're not in violation of any of that for this.
Oh,
Yeah,
okay.
I see. Thank you.
Right. But
Is this we?
Yeah, it's me. I have
Okay.
problem on a previous class, so I miss it.
Oh, so are you, you didn't go to the class last semester, right?
Yeah,
No, right? You didn't. Okay. Yeah, it's gonna be tough. Well, let Dave check on it and see. Maybe I can have a separate session with you to
right.
go some of the stuff that you missed. So let us
And
know, Dave, and then
all
I'll have a
right.
separate session maybe on the weekend with him. Okay. Okay.
Right.
yeah, of course.
If we cannot let you have the recorded file, then I can set up like a Zoom meeting for an hour or so with you to go over the stuff you missed.
Yeah, I very appreciate.
Okay. All right. Sound good.
Right. And as a final issue, Vun,
Hmm.
it may be just my old man's vision, but if we could look at in your terminal, increasing the font size by about 25%, I think it would make it easier to see what's going on your
Oh,
screen without
good point. Good
overloading the screen.
point. God, yeah, good point. I don't know how to do that, but let me see. You're talking about the X term, right?
Yeah, yeah.
Yeah, that's a good point, Dave. I mean, I didn't think about that. Okay, I'll think about what to do.
All right, all right. And it's
Yeah,
just a
yeah,
suggestion.
thanks.
We'll work on it.
Good, good. Yeah, thanks. Thanks.
All right. All right. Thanks, everyone.
See y'all Thursday.
Record.